Remember our last chemistry lesson? We talked about the periodic table, remember? We learned about the fascinating world of elements, each with its own unique properties. We discovered how hydrogen, the first element, differs from helium, its neighbor, and how elements down the line like iron and gold have their own special characteristics. We also emphasized how crucial the periodic table is, a roadmap guiding us through the complex universe of chemistry. Now, having refreshed our memories, it's time to dive into today's topic. Today we're diving deeper into the world of chemistry and exploring atoms and molecules. Let's start with atoms. Picture them as tiny building blocks, so minuscule that they're beyond what the eye can see. Each atom is a world in itself, holding protons, neutrons, and electrons in a delicate balance. Now, when these atoms want to make friends, they form what we call molecules. Molecules are groups of atoms hanging out together, bonded by forces that we'll get into in later lessons. Think of them as teams, where each player, or atom, has its unique role. Whether it's a molecule of water, oxygen, or sugar, each is a unique combination of atoms, forming a distinct team. So, from the air we breathe to the screen you're looking at, everything is made up of atoms and molecules. Atoms and molecules, simple yet profound. They are the fundamental units that make up everything around us. Let's delve deeper into understanding atoms, the smallest units of matter. Picture an atom as a tiny solar system. At the center of this system, we have the nucleus, a dense core made up of protons, which are positively charged, and neutrons, which have no charge. Orbiting this nucleus, much like planets around the sun, are the electrons, which carry a negative charge. Now, the number of protons in the nucleus determines an atom's identity. This is known as the atomic number. For example, hydrogen has just one proton, so its atomic number is 1. Whereas helium has 2 protons, so its atomic number is 2. Let's talk about atomic mass. It's calculated by adding up the number of protons and neutrons, the heavier components of an atom. Electrons, being much lighter, don't significantly contribute to an atom's mass. Different atoms or elements have different numbers of protons, neutrons, and electrons. For instance, a carbon atom has 6 protons, 6 neutrons, and 6 electrons, while an oxygen atom has 8 of each. These differences in structure give each element its unique properties. So atoms are like the ABCs of the universe, each with its unique properties. Understanding these tiny building blocks can help us unravel the mysteries of the matter that makes up everything we see, touch, and feel around us. Now, what happens when these atoms decide to join forces? They form what we call molecules. Imagine atoms as social butterflies. They love to interact and form connections. This process is known as chemical bonding, and it's the force that glues atoms together to create molecules. When atoms bond, they share, donate, or accept electrons to achieve stability. This desire for stability, in essence, is the driving force behind the formation of molecules. There are 3 main types of chemical bonds: covalent, ionic, and metallic. Covalent bonds form when atoms share electrons. Think of it as a friendship where both parties contribute equally. This is common between non-metal atoms. The water molecule, H2O, is a classic example of a covalent bond. Ionic bonds, on the other hand, are more like a give-and-take relationship. One atom donates an electron to another, creating positive and negative ions that attract each other. This usually happens between metal and non-metal atoms. For instance, sodium donates an electron to chlorine to form the molecule sodium chloride, our everyday table salt. Lastly, metallic bonds occur among metal atoms. In this type of bond, electrons are shared and move freely among a sea of atoms, which gives metals their unique properties like electrical conductivity and malleability. But here's the fascinating part. The properties of a molecule are different from the atoms that make it up. For instance, hydrogen and oxygen are both gases at room temperature, but when they combine to form water, they create a liquid. It's like magic happening right before our eyes, except it's not magic, it's science. In this marvelous world of molecules, even the smallest changes can make a big difference. Just by rearranging atoms, you can create entirely different substances. Molecules, therefore, are like words formed from the alphabet of atoms. Each molecule tells a unique story, and it's up to us to uncover the tales they hold. Today, we embarked on a molecular journey understanding atoms and molecules. We began by establishing atoms as the fundamental building blocks of matter, the tiniest particles that still retain the properties of an element. We then delved into the structure of an atom, exploring the nucleus at the center, which houses protons and neutrons, and the orbiting electrons that whirl around this nucleus in defined energy levels. Our journey then led us to the realm of molecules, where we saw how atoms join hands, or rather share or exchange electrons, to form more complex structures called molecules. The amazing variety of substances around us, from the air we breathe to the water we drink, owes its existence to these tiny atoms and the molecules they form. In our next lesson, we'll explore the fascinating world of chemical reactions. So stay curious and keep exploring.